We'll continue with the discussion of DTFS from the linear algebra perspective. We want to study B1. B1 is the column B1 of matrix B. From the previous slides, we see that we now know how to generate the B1 column. Simply, we take different n and substitute here, and we use k equals to 1 for B1. And therefore now we will have different values at different n entries. But what does it mean? What does these vectors look like? First is they all actually have magnitude 1, because the first one is 1, the second one is 1e something, second one is 1e something. So it is a complex exponential with radius 1 for all the elements, but with different phase, that's all. Because you should look at it as 1ej theta, and this theta is nothing but this value 2 pi over n, 4 pi over n, and so on. And so I will draw for you now. This is B1, and this is n equals to 0, 1, 2 until n minus 1, so which is 7. I'm drawing for you the unit circle with radius 1. So this circle has radius 1. So this is the real part of Z, and this is the imaginary part of Z. So this arrow here, now I will draw in, let's say in green color. This has radius 1, and it has angle 0 because angle is with respect to the positive real axis anti-clockwise. Now, I draw the second guy. So this is, the angle is pi over 4, which is 45 degrees. The third one is angle pi over 2. So at every step, I move from this point to this point to this point. At every step, I am moving by pi over 2. So if I call this the first signal, and then this is second, this is the third, you will see that actually the phasor is rotating anti-clockwise, because at every step I am moving by pi over 4. So I will take 8 steps before I move all the way back. So let's count: 0, 1, 2, 3, 4, 5, 6, 7, and on the 8th step I will move back to this point. Now let us study this graph, this picture here. The B1 columns, the entries, first is along this horizontal line, means amplitude 1 phase 0, amplitude 1 phase pi over 4, amplitude 1 pi over 2, and so on, and it rotates anti-clockwise until the last one, which is actually at this 1.75 pi, is it? And then, or we can say minus pi over 4. So what is B1 now? B1 is a complex exponential rotating anti-clockwise with amplitude 1 with digital frequency pi over 4 radian per sample. Now if you understand what is B1 now, go through the pictures very carefully. The other way to look at it is we will put it in a polar plot, and now you'll see that it is this dotted point which represents each of these elements as n progresses, and they are rotating at 2 pi over n, which is in this example n is 8, 2 pi over 8 is pi over 4. Here give you the details of the value of B, first column, first element. So this guy is k, this guy is small n, this guy is k, this guy is small n, and you will see that you can work it out first by substituting this k and n to get it in rectangle form, followed by the polar form. Of course, the last value I also calculated for you. This is k equals to 1, and small n equals to 7. Then I calculated as 1, which is magnitude 1, and the theta is 1.75 pi. Now, what's the other cool interpretation? What's B2? B2 is the second harmonic of B1. If B1 is the first harmonic, this is a zero harmonic. He doesn't change. There's no frequency. He's not changing. Okay, he's a DC value, constant value. He's always 1. This guy rotates 1 complete round, 2 pi round in n samples, in 8 samples. This guy, B2, completes 2 rounds in 8 samples. B3 completes 3 rounds in 8 samples. So how do I see this? Let's see this. In B2, the first elements, all starting points are the same. In one sample, instead of transversing by pi over 4, he transverses by pi over 2. So he moves by 90 degrees. This guy moves by 45 degrees. Moves by 90 degrees again. So therefore, since he's 2 times faster, he will complete 2 rounds. This guy moved 3 rounds because in the first step, he already moved 3 times more than this guy. So on and so forth. So that is B1, B2. What about B7? So of course you think that he moves 7 rounds. That's one interpretation, but it's more interesting to interpret it that 7 rounds means actually minus 1 round, because you look, he is moving, instead of moving anti-clockwise, he's now moving clockwise by pi over 4. So you see that in 8 samples, he moved 1 round, but in the clockwise direction. Compared to B1, he moved 1 round in the anti-clockwise direction. So this is the very important interpretation of k equals to 7 frequency is the same as k equals to minus 1 frequency, which is why the frequency representation is 2 pi periodic. Right, I give you more interpretations. I now draw again B1 over here. So now B1, you understand it as 1 rotating phases in the anti-clockwise direction. So I will now draw it in 3D over here. The phasor is rotating anti-clockwise. This is the real axis, this is the imaginary axis, and this is time. And I have 8 samples, and in 8 samples, it'll move exactly back to here, this point. 0, 1, 2, 3, 4, 5, 6, 7. The 8th point is the same as this point in the real axis. It's rotating anti-clockwise. This you see in 3D. This you see in 2D. The first point is here, second point, third point, and so on, anti-clockwise. If you prefer to see in the real and imaginary, you can see the real as well as the imaginary. Now you can interpret why he moved anti-clockwise. You look at the first sample, the real is 1, which is here. The imaginary is 0. That is why real is 1, imaginary is 0. The second point, we move by pi over 4. So the cosine decreases as n increases, and the sine increases. The sine is represented by the positive j omega axis. So he's going up j omega. Therefore, the cosine from this point moves down, but the sine goes up, and that is why in one sample he rotates anti-clockwise. So this is the reason why the omega equals to pi over 4 results in an anti-clockwise direction. Okay? Alright, so that's of course provided no aliasing has occurred yet. Okay, so you guys have to be careful about that. What about B2? B2, now we see why 8 samples rotate 2 rounds. We can only see the dotted, the blue line associated with it is just a sketch to show you the direction. But you see that when it transfers faster and faster, then you can't really interpret it very easily anymore. But that's the idea that of k harmonic. B1 is 1 round anti-clockwise in n sample. B2, 2 rounds. B3, 3 rounds. It goes faster and faster. With this interpretation, I hope now you can understand the columns of B. Thank you.